Hi and welcome back to our FreeFlyer Fundamentals training video. This is part 3 of 3, so if you haven't completed parts 1 and 2, please go back and do that now. In this section of our training, we're going to go over FreeFlyer Procedures, debugging a mission plan, working with output window objects, and improving your visualizations. For our hands-on examples, we're going to continue building on the same mission plan that we've been working on in parts 1 and 2 of this video. We're going to be creating a FreeFlyer procedure and customizing our output windows. Okay, let's learn about FreeFlyer procedures. Already in this training, you've seen how we can use FreeFlyer script to create and modify objects, create output windows, and in general control your whole simulation. FreeFlyer procedures let you place commonly used sections of your FreeFlyer script inside a function that you can call from any point in your mission plan. You can save a procedure inside your mission plan, or you can save it in a separate text file to make it easy to call the procedure from multiple different mission plans. You can pass any FreeFlyer object type, like a spacecraft object or variable object, as an argument into a procedure for input or for output. Learning how to capture useful sections of your FreeFlyer script inside procedures lets you organize your mission plans better for easier development, maintenance, and debugging. To create a procedure, we'll use the define procedure command, where you specify the name of the procedure and the list of arguments that are required, and you close the procedure with an end procedure command. The script example shown here defines a procedure called apply rotation and passes in two arguments, a spacecraft object and a variable object. Inside the procedure, you'll enter your FreeFlyer script. Once you've defined a procedure, you use the call command to invoke the procedure from anywhere within your mission plan. In this example, you can see that we're calling the apply rotation procedure and we're passing in a spacecraft object and a variable containing the angle for the rotation. As I mentioned, you have the option of saving your procedures in a separate file so that you can easily share them across different mission plans. When you use that approach, you need to include the procedure in the mission plan, either using the include command or through the externals menu. A sample of the include command is shown here, where you simply specify the include command followed by the name of the procedure file. This can be a relative path or a full path to the location where your procedure is saved on your machine. Or you can use the externals menu to add procedures to your mission plan. One benefit of that approach is that you can syntax check the procedures right within the FreeFlyer development environment. Next, we'll talk about debugging a mission plan. FreeFlyer includes a debugger that lets you examine the status of a mission plan while it's running. When you're debugging a mission plan, you can view the value of any object or property in the inspector window. You can also edit values through the inspector, or you can simply hover your mouse over any object or property to see its current value. The screenshot on this slide shows an example where we're debugging a FreeFlyer mission plan and hovering over the variable called myVariable, and the mouse over shows that the current value of that variable is 16. To launch the FreeFlyer debugger, you can set a breakpoint on any line of script by clicking in the left-hand margin. You can also select the option to run and break into the debugger as soon as your mission plan starts running, which you can access through the down arrow button right next to the Run button. You can also right-click on any line in your FreeFlyer script and select Run to Cursor. That will run the mission plan and then enter the debugger when you reach that line. Or while your mission plan is running, you can pause it and click Break on the debugger toolbar. I'll point out the debugger toolbar in FreeFlyer as well, but the screenshot here shows the buttons that are shown on the toolbar. We have the Break and Continue buttons, and then the Step Over button, which will step line by line through your script. And then there are Step Into and Step Out buttons for stepping either into a procedure or stepping out of a procedure. We're going to practice the topics that we just covered by creating a procedure in the mission plan we've been working on. In the last section of this training video, we made a section of FreeFlyer script that counts up the number of visible satellites in a formation. That section of script is actually pretty useful, and if we take that section of our existing mission plan script and move it into a procedure, it's easy to call that script from any point in the mission plan. In general, putting useful sections of FreeFlyer script into procedures will help improve your organization and make it easier to expand your mission plan and add complexity without having redundant sections of script. The example we're working on right now is a pretty simple mission plan, but it's useful to get some practice with creating a FreeFlyer procedure. So we're going to take that section of script that you've already typed and we'll move it into a procedure and then call the procedure from the mission plan. So here's what we'll do. We'll add a new freeform section at the beginning of your mission sequence, and then we'll type in the definition for a procedure that will be called number visible GPS. We're going to be passing 3 arguments into the procedure: a spacecraft object, the GPS formation, and then the variable numGPS, which will return the result of the procedure calculation. So here we have the mission plan that we've created so far in this training tutorial. I'm going to add another freeform section to the top of the mission sequence, and I'm going to label this define procedure. And inside this freeform, I'm going to start filling out the skeleton of the procedure. We use the define procedure command and then give the procedure a name. And then specify what arguments need to be passed into this procedure. Then we close the procedure with an end procedure command. Next, we'll fill in the contents of the procedure. Okay, so up next we're going to fill in the contents into this procedure. First, we're going to create a variable called I inside the procedure, and then cut and paste the for loop that we already typed, the one that's shown below here where we're looping over the GPS satellites and counting up how many of them can see the spacecraft. We'll cut it out of the mission sequence where it was before and paste it into the procedure. Notice how inside the procedure the spacecraft isn't called Spacecraft 1 anymore, it's called SC, and so make sure to change the reference to the name of the spacecraft to match the procedure definition. Okay, so in FreeFlyer I'm going to navigate to the freeform section where I had my for loop that loops over the GPS formation, and I'm going to cut that section of freeform script, go to where I'm defining the procedure and paste it, and change the name of the spacecraft object from Spacecraft 1 to SC, because when we pass the spacecraft into the procedure, we're giving it a local name of SC. And then the last thing we have to do to set up this procedure is create the variable called I. You'll remember that we did create a variable called I that exists in the mission plan, but that object is not being passed into this procedure. That object isn't visible inside the procedure, and if I were to do a syntax check right now of the procedure, I get an error message saying that the identifier I is not defined, because although it does exist in the mission plan, it hasn't been passed into this procedure. I could pass that same variable I into the procedure, but for this example, I'm just going to create the variable I inside the procedure. Now that we've defined this procedure, all we need to do is call the procedure from the main while loop part of our mission plan. So all we need to do is enter this call command where we're calling the number visible GPS procedure and then passing in the spacecraft object, the GPS formation, and the numGPS variable. Notice how the arguments that we're passing into the procedure can have a different instance name inside the procedure scope compared to in the main mission plan scope. Specifically, instead of referring to the spacecraft as Spacecraft 1, inside the procedure it's referred to as SC. And then once you've set that up, we're going to save, syntax check, and run the mission plan again. The output should look exactly the same as last time because the functionality of the mission plan is the same, but we've gotten some good practice at organizing our FreeFlyer script and using a procedure and calling it from the mission plan. Okay, so now that I've defined the procedure, I'm going to return to the section of freeform script where I used to have that for loop, and I'm going to replace it with a call to my procedure. So I'll use the call command and then start typing the name of the procedure we defined, number visible GPS, and you can see that FreeFlyer recognizes that this is a procedure that's been defined and is included in this mission plan. and so I don't have to type the whole name. I can just hit enter or space to complete. And then FreeFlyer also recognizes what type of arguments are expected to be passed into this procedure. So I know, without having to look back at the procedure definition, that FreeFlyer expects to have a spacecraft object, and then a GPS formation object, and then a variable for the num GPS passed in as arguments into the procedure. So now I'll save, syntax check, and run the mission plan again. So the output of this mission plan looks the same as it did the last time we ran it. It's important to note that the results on the plot showing the number of GPS satellites that are visible from the low Earth orbiting spacecraft looks the same as it did previously. So the same calculation is being done, but now that script is encapsulated inside a procedure that can be easily called from anywhere in the mission plan. Next, we're going to talk about working with output window objects in FreeFlyer. You've already seen how we've used the view command, the map command, and the plot and report commands to generate output in FreeFlyer. I mentioned earlier in part 1 of this training video that those commands let you generate output very quickly and easily, but that there isn't a whole lot that you can do to customize the views that are generated. So now I want to introduce the topic of output window objects. For every output command that we've talked about in FreeFlyer, there's a corresponding output window object. The table here shows a summary. When you're using the view and map command, if you want more control over the view that's generated, you can use the corresponding view window object. For each of the different plotting commands that we talked about earlier, if you want more control over the plot style, you can use the plot window object. Instead of the watch command, you can use the watch window object, and instead of the report command, you can use the data table window object. Using these output window objects gives you a lot more control and customization options compared to just using the view command, for example. Once you've created one of these output window objects, you use the update command to send new data to the output window. Let's talk in some more detail about the view window object. As I mentioned, the view window can be used instead of a view or map command to create more customized views. Every view window object that you create can contain one or more viewpoints. Not only can you create 3D view and 2D map viewpoints, but you can also create sensor viewpoints, celestial sphere views, and star map views, as well as rotating pulsating viewpoints and blockage diagram views. You can also control everything about how each object in the view is displayed. For spacecraft objects, you can control the color, font, line width, the history length, and the icon used to draw the spacecraft object. You can have detailed control over the Earth surface textures and lighting settings. You can control ground station and sensor opacity settings and the projection height for how those cones are drawn. And you can also set the window title so that instead of just saying something like Mission View 1, you can set a customized title for that view. Here we have some examples of each of the different viewpoint types. We have a star map viewpoint, a 2D map viewpoint, a rotating pulsating viewpoint, a sensor viewpoint, a celestial sphere viewpoint, a 3D view, and a blockage diagram view. I also want to take a moment to talk in more detail about the View Output Properties tab that you've probably noticed shown on the right-hand side of the output screen whenever you're running a mission plan. From the Output Properties tab, you can print or export a view of the screen, you can switch between viewpoints, and you can also manually edit the viewpoint while the mission plan is running. If you click on the All Output Properties button, you get another panel that lets you modify, add, and delete viewpoints from the view window that you're editing. You can modify the display settings for all the objects in the view, and you can also capture the view configuration and export it as an XML file. If you want to reuse those exact same view configuration settings later on, you can import that XML file back into a mission plan through FreeFlyer script. The plot window object can be used in place of the plot command, polar plot, monitor, or polar monitor commands to let you create much more customized plots. You can configure the plot title and subtitle, settings for the legend and the plot grid lines and the background colors. You can also control everything about the axis labels, spacing, the minimum maximum values shown on the plot, and then for each series in the plot you can control the color, line style, marker style, and also set custom labels to be drawn on each data point. The screenshots shown here give you an idea of how much control you have over customizing the look and feel of your plots. When you're running your mission plan and looking at the output screen, if you have a plot window selected, the Output Properties tab on the right-hand side of the screen shows you some different options. You can still print or export the plot, and you can also change some settings like the line width and the marker size. And then again, if you click All Output Properties, you'll get a panel that lets you modify all the settings of the plot. The Watch Window object and the Data Table Window object can be used in place of the Watch command or the Report command. The only real benefit that you get from using these window objects instead of the commands is that you're able to set the title for the window so that it doesn't simply show Watch 1 or Report 1 for the window title. So we're going to go back to our hands-on example one more time and customize the output windows that are shown in this mission plan. In part 2 of this training video, we set up 2 different spacecraft that both have the same initial state but are propagated with 2 different force models. We added a plot showing the orbital separations over time, but now we want to create a close-up 3D view showing the orbital separations between spacecraft 1 and spacecraft 2. And to do that, we need to create a view window object and set up a custom viewpoint. We're also going to practice customizing one of our plots by replacing one of our plot commands with a more sophisticated plot window object. So the plan will be to add a view window with a customized spacecraft-centered viewpoint. We'll add a plot window and customize the plot style, and then we'll add update commands within the mission sequence. So first we're going to go back to FreeFlyer, add a view window object in the object browser, and edit it. On the content page, we're going to check the boxes to show the spacecraft 1, spacecraft 2, and the GPS formation. And then we can select the 2 spacecraft objects and turn off the option to show body and turn on the option to show name. Go ahead and choose a custom font choice, like the font Magneto, set the tail history mode to unlimited, and set the line width to 3 pixels. So we'll continue by adding a view window object. Double-click to edit the view window, and on the content page, we're going to check the boxes to display the GPS formation and the 2 spacecraft. You can hold Shift to select both of the spacecraft. And for this close-up viewpoint, we're going to turn off the spacecraft body, but turn on the names. And instead of using the default font, you can choose a custom font. Then set the tail history mode to unlimited. That controls how long the tails are shown in the view. And increase the line width to 3 pixels. Next, we'll move on to the Viewpoints page. On the Viewpoints page, we're going to modify the default viewpoint and change it to a spacecraft-centered close-up view. We're going to set the source and target settings to point to spacecraft 2, and we'll modify the camera properties to set a nice close-in view, so we'll edit the right ascension, declination, and radius settings. When you're setting up your own viewpoints in 3D views, it's good to remember that any object can be the center of a 3D viewpoint, whether it's a spacecraft, ground station, or celestial object, for example. To set up a 3D viewpoint where one object is at the center of the view, you want to set both the source and target settings to point to that object. You can also choose whether to have an inertial view or a body fixed view with respect to that object. After we finish editing our viewpoint, we're going to add an update command into the while loop and run our mission plan again. So I'll go ahead and edit my viewpoint to match what was described in the slides. I'm going to set the source and target objects to spacecraft 2. I can use the copy to target button here. And then the right ascension we want to use is 55 degrees, declination of 15, and a radius for the camera will be 0.8 kilometers. Next, all I need to do is drag and drop an update command into my while loop. Now I'll run the mission plan again. In this new view window, which appears at the top left for me, we can see spacecraft 2 at the center of the view. It's shown in red, and then spacecraft 1 is being drawn in orange or cyan depending on whether that spacecraft is in light or shadow. We can see in 3D the differences in the orbit propagation based on the different force models that we set up for each of these 2 spacecraft. If I manipulate the viewpoint, I can see the Earth in the background. Next, we're going to take out the plot command where we were plotting the num.gps variable, and instead we'll replace it with a customized plot window. Go ahead and comment out or remove the plot command where we're plotting num.gps, and then add a plot window object in the object browser. Edit the plot window, and on the y-axis, configure it to plot the num.gps variable. Then on the plot properties page, click the All Output Properties button and customize the plot style. You can set the plot title to say something more descriptive like number of visible GPS, and customize the plot title font. On the chart area page, set the interlaced direction to horizontal and set high quality rendering to true, and then on the series properties, select the num.gps series and customize the line and marker colors and styles. Then drag another update command into the while loop. This one is going to be set to update plot window 1, and then save and run the mission plan again. Feel free to take some time to explore the different options on the plot window and the view window and create an interesting customized visualization. So first I want to go into my mission plan and find the plot command where I was plotting the num.gps variable and comment that out, and then I'm going to add a plot window object. I can find all the different output window objects under the Output section of the Object Browser Add menu. On the y-axis of this plot window, I want to choose the num.gps variable. And then on the Properties page, I'm going to click the All Output Properties button. And I'll set the plot title to Number of Visible GPS. Feel free to take some time to make other changes to the plot titles and legend settings. On the chart area page, I'm going to set the interlaced direction to horizontal and turn on high quality rendering. And on the num.gps series page, I'm going to set the line color to orange, increase the line width, set the markers to visible, and set the marker color to red. You can also feel free to customize the settings on the x-axis and y-axis display. And I almost forgot to go back and set a custom font for my plot title. Next, we need to add another update command into our while loop. When I add the new update command, it chooses the first window object alphabetically, so conveniently it automatically selects the plot window that I just created. Now let's go ahead and save the mission plan and run it again. Now you can see we have the same plot that we had before in terms of plotting the number of visible GPS satellites, but I've completely customized how the plot is displayed. Feel free to take some time and continue to play with the settings for the plot window and the view window to customize your output. Remember that with the view window, you can add multiple viewpoints of different types, such as 2D map views, celestial sphere views, or star map views. This completes the hands-on portion of the FreeFlyer Fundamentals training. We've built up this fairly interesting mission plan through the series of 6 hands-on exercises. We have one more bonus topic left where we're going to talk a little bit more about how to continue to improve your visualizations. But I hope you can feel proud of how much you've accomplished in setting up this pretty cool mission plan, especially if you're brand new to FreeFlyer. Now we're going to go over a few more topics about how to improve your visualizations in FreeFlyer. We're not going to do a hands-on example to practice using these different features, but they're really useful to know about. First, we'll talk a little bit more about working with Spacecraft 3D models. Obviously, you can make your visualizations more realistic by choosing a 3D model that represents your actual spacecraft mission. This can be as easy as opening your spacecraft object editor and browsing to a 3D model file. You can easily control the scale of the model in the views. If you want to model an articulating 3D model, you can also use a more sophisticated option, which is to use a 3D model object in FreeFlyer and then associate that 3D model object with a spacecraft object. Using a 3D model object lets you control the size, orientation, and position of individual components within the model, and also lets you compute whether a line of sight intersects with the 3D model itself. This list shows the file formats that FreeFlyer supports for 3D models. The Graphics Overlay Object is a very powerful object in FreeFlyer that lets you create custom graphics by drawing completely arbitrary lines, points, triangles, triangle strips, and then also icons and text annotations. These two screenshots show examples of how powerful this feature is. In the image on the right, we're using graphics overlay lines to represent the Earth's gravitational field, and in the image on the bottom, we're using lines to represent the Earth's magnetic field. While the graphics overlay object lets you display objects that are in the same space as the Earth and the spacecraft object, the window overlay object lets you display text and graphics that are drawn at a fixed point on your screen, always in the foreground of anything else that's in the view. This example shows a window overlay drawn in the top left corner of the screen to display a spacecraft's latitude, longitude, altitude, and some other information. You can customize the display of the globe of any celestial object in FreeFlyer, such as the Earth or the Moon. You can control what surface textures are drawn. You can turn on and off the rendering of the clouds. You can also draw coastlines and political boundaries. In this image, we're showing global Earth coastlines as well as U.S. state borders and global country borders. You can also create custom lines and location markers that will be rendered on the globe surface. We briefly used the Color Tools object earlier in this training to set the color of a spacecraft object. The Color Tools gives you an interface for a long list of standard colors that you can access through FreeFlyer. The Color Tools object also lets you interpolate two colors to create a gradient, and so this is really useful if you want to visualize a range of values. FreeFlyer also lets you control how the output windows are arranged within the output workspace when you run the mission plan. The Output Layout Manager object lets you control the size and the location of output windows. It also lets you set the whole workspace to full screen or set an individual window to full screen. You can hide the window frames and configure custom tiling or picture-in-picture setups. You can also unconstrain windows and drag them out of FreeFlyer entirely. And you can also use the Output Layout Manager to resize the main FreeFlyer window programmatically. All of this is available through the Output Layout Manager object in FreeFlyer script. Finally, I also want to point out that you can generate a movie of any FreeFlyer view window. All you need to do is enable recording by pressing the red circular button on the navigation bar right next to the Run button before running your mission plan. Then once the mission plan stops running, a dialog will pop up that will let you specify all of the settings for rendering your video. In closing, I just want to point out some of the additional resources that you have available as you're learning FreeFlyer. We've covered a lot of topics throughout the course of this Fundamentals training class. In the FreeFlyer help file, you can find a lot more detailed information on all of these topics. In particular, if you explore our Guides section of the help file, the guides on spacecraft propagation, generating output, and FreeFlyer scripting go into a lot more detail on the main concepts that we focused on throughout this particular training video. The help file also provides property and method tables for all the objects in FreeFlyer, and so if you want to know more detail about a particular property or method that we talked about, or any of the options that are available on the objects in FreeFlyer, you can find all of that in the help file. Of course, there's also detailed information about all the commands and functions in FreeFlyer. And then the appendix is also a really useful resource. In particular, it talks about different data files that FreeFlyer uses and provides more detail on the ephemeris formats that FreeFlyer supports. You also have dozens of sample mission plans that were included with your FreeFlyer installation. For the examples that are most relevant to this Fundamentals training class, make sure to check out the sample mission plans in the propagation folder, the generating output folder, and the FreeFlyer scripting folder. Finally, as you're learning about FreeFlyer, if you have any additional questions that aren't answered through the help file or the sample mission plans, please feel free to reach out to us by email or phone. Thank you for tuning in and following along for our FreeFlyer Fundamentals training class. I hope this helps you get off to a great start in your use of FreeFlyer.